Hi there, we're going to start the review again on number 26 where we left off. So we were talking about mutually exclusive and not mutually exclusive or inclusive events. So it says look at the situation of the following problem and see if you can find the error. There's definitely a mistake, so correct the error if you find the correct answer. So it says the probability of drawing an ace. The probability of drawing an ace out of standard deck of cards is there's 4 aces out of 52 cards. Now, the probability of drawing a black card is half the deck is black, so it's 26 out of 52. Well, so that's what this is. But are there any aces that are also black? And there are aces that are also black. So I have to subtract that intersection from our formula from the last video. So in this case, it's actually going to be 28 over 52, which is 7 over 13 would be our answer. And it is not mutually exclusive because there is an intersection there. So I kind of went through and already did this one and labeled each problem whether it was inclusive or mutually exclusive. So let's move on to independent and dependent events. So independent events, they do not affect each other. Do not affect each other. And the denominator changes. When I add the two, or when I multiply the two probabilities together, or the 3 probabilities together, my denominators are always the same. A dependent event is they do affect each other, meaning that the denominator will change. And we'll go through this and explain it a little bit more in a second. They do affect each other. The denominator changes. This means, for instance, without replacement, because then the out of or the possible outcomes is different. This is I eat a piece of a candy that I took out of the candy box. So let's apply that concept. So it says a bag contains 9 marbles and 9 red marbles and 3 green marbles. So there's a total of 12. So bag B, so that's 12 total. And then bag B contains 9 marbles and 9 black marbles and 6 orange marbles. So that's 15 total marbles. Find the probability of selecting 1 green from bag A. So the probability of selecting 1 green from bag A is 3 over 12. And so I'm going to multiply 1 black marble from bag B. So then the probability of drawing a black marble is 9 over 15. And one does not depend on the other, so they are independent events. Okay? Now, the denominator here did change because it's different bags, so be careful with that one. So then I just multiply straight across, and then from there, I don't think that's right. 12 times 15 does not equal 60, so you need a handy-dandy calculator. 12 times 15. And that's going to be 180. So 180, that doesn't seem right, but it is. And then, so then I simplify, and it's 3/20. So it is an independent event, and it is 3/20. 2 seniors, 1 from each government class, so it's different classes. So in this case, it's going to be independent again. Selected to travel to Washington, D.C. Wes is in a class of 18 students, so the probability of choosing Wes is 1 out of 18, and Maureen is in a class of 20. So the probability of choosing Maureen is 1 out of 20. Find the probability that both Wes and, so that tells me I multiply, Maureen will be selected. So I have 1 out of 18, 1 out of 18 times 1 out of 20. So my chances are 1 out of 360. If there was only 1 government class and Wes and Maureen were in the class, that class of 38, what will be the probability that both Wes and Maureen will be selected as the 2 students to go to Washington? Is this example still independent? No, it is now dependent. They're in the same class. So basically the probability of picking Wes is 1 out of 38 because there's 38 kids in the class. And the probability of picking Maureen would be now 1 out of 37. So I take my 2 fractions, and because it's an and situation, I multiply them together. and the probability would be 0.0007, or would be 0.07%. So very unlikely that both of them would be selected. So moving on to the next page, we have a box contains 5 marbles, 3 green ones, 2 orange ones. 2 consecutive draws are made from a box without replacement, therefore it is dependent. Find the probability of each event. So I have 3 green, 5 purple, 2 orange, so a total of 10 marbles to begin with in the bag. So my first is going to be orange, so the probability that's going to be orange is 2 out of 10, and then I want my second, so my first is orange and my second is green, and then that's 3 out of 9, therefore it's 6 out of 90, which is 2 out of, so 6, we'll just simplify using our handy dandy calculator, 30, which is 1 over 15. Both marbles are purple, so the probability that the first one is purple is 5 out of 10, and the probability that the second one is purple is 4 out of 9, because I've taken one of those purples out and I've taken 1 marble out of the bag. So this would be 20/90ths, which would be 2 ninths. The first marble is purple, and the second marble is any color except purple. So the first marble is purple is 5 out of 10, and then the probability that the second is any color except for purple is basically 3, 4, 5 out of 9. So 25 out of 90, which would be simplified 5 out of 18, or 5/18. If you draw 2 cards from a standard deck of 52 cards without replacement, find the probability that you draw a king first and the jack second. So again, it's and, so I'm going to multiply. So the probability of drawing a king is 4 out of 52, and the probability of drawing a jack is 4 out of 51, because I've taken one of those cards away. So I use my calculator and it will simplify for me, and I have to put multiply in there, multiply, and my answer is 4 out of 663. The probability that a face card is first, so I have 12 face cards out of 52, and an ace is second. I have 4 aces out of a total of 51. So I have 12 over 52 times 4 over 51. 12 over 52 times 4 over 51. And my answer is 4 over 221. And then the probability of drawing 2 aces is 4 out of 52 times, now there's only 3 aces left out of 51 cards. So I say 4 out of 52 times 3 out of 51, and that simplifies to 1 over 221. So moving, I will tape another video with the rest of them, and we'll pick up at number 32.